Hello everyone and welcome back to Hub360 Circuit, your go-to channel for electronics tutorial, embedded systems and practical Arduino projects. Air pollution is one of the major environmental challenges affecting human health today. Fine particulate matter, especially PM2.5, is particularly dangerous because it can penetrate deep into the lungs and even enter the bloodstream, causing respiratory and cardiovascular diseases. In this project, I designed and built a smart air quality monitoring system using a PM2.5 sensor, an ESP32 microcontroller with an active buzzer. This system is capable of measuring real-time air quality, sending data to the cloud, displaying it on a mobile dashboard, and triggering an alert when the air becomes unsafe. So if you are interested in IoT, air quality monitoring, or building your own smart environmental system, this project is for you. Now I am going to connect the entire system step by step. We'll be connecting the PM2.5 sensor to the ESP32 and a buzzer for alert and powering the system properly. Our PM2.5 sensor uses UART serial communication, so we'll connect it using RX and TX pin. So first of all, we'll connect our VCC to 5 volts. And then we'll connect ground to ground. And I will connect my TX to GPIO 16. And then I'll connect my RX to GPIO 17. And then for the buzzer, I'll connect my signal pin to pin 23. Connect my VCC to 5 volts. And then my ground to ground. So guys, now I will walk you through the software setup for this project. These lines, they connect the ESP32 to Blynk platform, the template ID, the template name and the authentication token. This is our library Wi-Fi.h for internet connection. The Blynk simple ESP32.h is for Blynk communication, and then we added our PM2.5 sensor library. So then we configure the SSID and password for our Wi-Fi, and then we define the various pins, our buzzer pin, and then this is where we set the threshold of the sensor. When it gets above this threshold, the buzzer should come on. So and then record. In here, if the sensor is detected, the system stops the execution. So yeah, this particular line, it creates an object called AQI from the PM2.5 sensor library. And then this Blynk timer, this creates a timer object used to run functions at intervals, meaning it helps you send data to Blynk automatically every few seconds instead of using delay. Now this line, this creates data structure like a container to store readings from the sensor. It holds values like PM1.05, 2.5, just like the values that is being read from the sensor. So this particular line is just to hold those values together. Now this line tries to read data from the sensor. Says if the reading fails, the function stops immediately. If successful, it continues. Now this extracts the PM2.5 value from the sensor, this particular line, and then it means if you are selecting the standard PM2.5 concentration in gram per meter cube to work with. It means you are selecting the standard PM2.5 concentration in microgram per meter cube to work with. Now, this is saying that if the value from the PM2.5 is greater than our threshold, then the display status should show air not safe, and then the buzzer pin should come on, and then also our serial monitor should print alert. Else, if otherwise, then the display status should show good air, then the buzzer pin should no tune, and then the serial pin should just show a good status. So that's basically what this particular line is all about. And also we also serial printed whatever that is being read from the sensor, the PM2.5, the unit, and then we serial print it to display. This is to send data to the virtual pin 1. Our gauge value is sent this to this pin, and then this virtual pin 2 is to send the labeled value to this pin. So here we initialize our serial communication. We set our baud rate to 115,200. Then here we set up our hardware serial. We set up our RX and 16 and then our TX and 17. Now this particular line, this checks if the sensor is properly connected and responding. It tries to start communication with the PM2.5 sensor. If it fails, it means the sensor is not detected. So it will serial print sensor not found if it can't communicate with the sensor. Here we initialize our Blynk. This is Blynk.begin, set up our authentication token, the SSID, and then the password. And then this timer.set interval is trying to tell you that it should read the value that is being sent to it should read the value from the sensor every 2 seconds, and this helps to keep the Blynk stable. And then this is under our loop. We are trying to say that send the this Blynk.run keeps your ESP32 connected to the Blynk server. It handles sending sensor data to your phone and receiving commands from the app. While the timer.run, it runs on functions scheduled with the Blynk timer. This Blynk.run keeps your ESP32 connected to the Blynk servers. It handles sending sensor data to your phone and receiving commands from the app, like button presses and the rest. Then the timer.run reads all functions scheduled with the Blynk timer. Now let's set up the Blynk IoT platform. I create a new template. I can name it Air Quality System. I select my hardware ESP32 and connection Wi-Fi. Then I click on Done. Next, I create data stream. Select virtual pin. Then I can give it a name, Wi-Fi start. Then I can give it a name, air start, air value, air quality status, air quality value. Then I'll select my pin VO. I put my min and max to 500. Then I click on create. I create another data stream and link it to V2. Name it air quality status. V1. Then this will be a string. Then I'll click on create. So that way I have created my data streams. Then I will save. So I will go to my template. I need to delete and just delete this because the space given to me is filled up. And just go. Or let me use this for example. This was the one I used in setting up my code. So this is where you will get your template ID and your template name, also your template authentication token. So you can come to web dashboard. And this is where you can add your various widgets. If you want to add a slider, you just bring it here. But since that's not what we are dealing with, we are dealing with a label and a gauge. So you can just bring this here, then bring this here. This will go for our virtual pin, the first virtual pin we created. So just put it as virtual pin air quality gauge. So as you can see, we just select it, and then the same thing for the label. We just come here, select it, air quality status, you just select, and then you save. So after that, you just click save and apply. Then you copy your template ID and the authentication token. You copy it and then you add it to your code. That is what is used in connecting to the cloud. Now let's power up the system and test everything live. As you can see on the Blynk dashboard, the air status is showing good air and the buzzer is off. As you can see, the PM 2.5 value increases. The system detects the unsafe air and the status changes to air not safe. Now, the buzzer also turns on immediately. This confirms that the alert system is working properly. Now, when the air becomes clean again, you will see the value dropping. In this project, we successfully designed and built a smart air quality monitoring system using a PM 2.5 sensor, ESP32, and the Blynk IoT platform. We were able to measure real-time air pollution levels, process the data using ESP32, send it to the cloud, display it on a mobile dashboard, and trigger an alert when air becomes unsafe. During testing, we confirmed that the PM2.5 sensor provides real-time data, the ESP32 processes this data correctly, and the buzzer responds instantly to unsafe conditions. This system can be applied in smart home, industrial safety monitoring system, air pollution tracking, hospitals and offices, smart city systems. Overall, this project shows how IoT and embedded system can be used in real-world environmental problems using low cost and efficient technology. If you found this project helpful, don't forget to like, share and subscribe. For quality electronics components, check out Hub360 Circuit. Thank you for watching, and I will see you in the next tutorial.